Okay, welcome back. My God, this is loud. I have the power. Next up, we've got Steven Steneker talking about MongoDB replication and replica sets.
Cool. Can we hear me? Yes. Yes. Cool. Okay. So my name is Steven. I'm actually a software developer and sysadmin. And currently I'm a support engineer at Tengen Australia. So you may or may not know, but Tengen is the company that develops MongoDB. It's a New York-based company, but we have an office in Sydney, or have had an office in Sydney for the last 7 months now. So I'm going to talk to you basically an introduction to replication and replica sets, because there's a lot of details we can go into. If you have any questions, just fire away. So the agenda here is going to talk about the replica set lifecycle. So basically, what does it look like? What is it? A little bit about developing with replica sets, and then some operating considerations. So first of all, how many of you are actually using MongoDB at the moment? A show of hands, yes? And how many are using it in production? Cool. Okay, so has everyone heard of MongoDB? Do you know what it is? Okay, so MongoDB is it's a document-oriented, NoSQL database. Basically, it's optimized for performance, so performance and high availability. So what we're talking about today is replication, which is specifically a feature for availability and data redundancy. So why do you use replication? Basically, replication has a number of different benefits, but and basically, how many of you have actually woken up and you've had a server and it's fallen over? How many of you actually woken up and actually found out you have to manually fail over from a slave to a master because there is no automatic failover? If you have issues due to network latency or hardware problems, that's also a common thing which replication can address. And basically, there's different uses for replication. So you could use it just for normal processing of data. So maybe you want to have your data and you want to run analytics jobs. You want to run your analytics jobs without impacting the performance of your production rights. So your analytics jobs are predominantly read jobs, so you would run those off of a secondary in your replica set as opposed to taking down or affecting the performance of your primary. So basically, this is the replica set lifecycle. The minimum replica set that you have, well, you could actually have a replica set which is one node, but that doesn't make a heck of a lot of sense. So the general minimal replica set is a 3-node set. And this is basically, it works on it works on a quorum basis, which means that we have 3 nodes. If you have 3 nodes, you need to have at least half of the nodes available. So So if you had a 3-node replica set, you'd have to have 2 nodes available in order to elect a new primary. When you create a replica set, this is what it looks like. So you have a primary, you have 1 or more secondaries which replicate from the primary, and you have a heartbeat between all the nodes, and the heartbeat basically makes sure that the nodes are actually available. So in the event that one of the nodes has an issue, so it fails to respond to the heartbeat, there's a certain delay where we'll actually look at it and decide whether the node is actually down or not. And at that point, the node will actually fail, and it'll fail out of the replica set. And there will be an election. And the way the election works is it basically looks at the nodes that are currently available in the replica set and decides which of the nodes is most up to date, is there a majority of the nodes visible, and then elects a new primary. So when we fail over here, we've got a node that's failed. The 2 secondaries will have an election between themselves, and then a new primary will be elected. So this happens automatically. This is basically auto failover. In a replica set, there's a single master in MongoDB. So basically, it's just a primary and then multiple slaves off the primary. When the node that's failed comes back, or returns, it will automatically reconnect to the replica set. It will determine which node it can actually sync from. If the node still has a current amount of data on it, basically it can still rejoin the replica set, and it hasn't fallen too far behind, then it'll basically resume syncing from where it was previously. If the node falls too far behind and can no longer sync with the replica set, then it'll actually do a full resync from the primary or the nearest node. So once the node recovers, then it'll actually resume its role as a secondary, and replication will continue. So let me know if I'm going too fast here, because I'm actually trying to cover a fair bit of things. So I'm going to look here now at the actual replica set roles. So in a replica set, a typical replica set, you've got three main roles that you can have. First node is the primary. The primary is the master, where you can write. You can only write to the primary, and those writes are then replicated to the other nodes. A secondary is a data-bearing node. So secondary is basically a node that's available for reading. You can't write to a secondary directly. And you can have different configuration options for secondary. So if you want to have a secondary which is, has a delay or perhaps is hidden, so you only use it for certain uses, you can do that as well. And the third type of node here is an arbiter. And an arbiter is a non-data-bearing node. An arbiter is basically a node that exists in order to vote in elections. So if you have, the reason that we have, actually I should have back up a bit. In a replica set, generally you need to have an odd number of nodes. And this is basically to avoid net splits when you have a quorum. So to have a quorum when you have a net split. So if you have three nodes, and any one of those nodes is down, the other remaining two nodes can still vote and say, we have a majority of the replica set visible, so we can elect a new primary. If you only have two nodes, and the network between the two nodes gets disconnected, then basically both the nodes could try and declare themselves primary, and that would be a bad thing. So in MongoDB, you can only have, you need to have a quorum available with the replica set enabled in order to elect a new primary. So the arbiter is basically there as a non-data-bearing node that can act as a tiebreaker. So if you don't want to have another server provisioned which is a full data-bearing node, you can set up an arbiter for that. So this is a configuration file which shows well, one sort of deployment. So basically in this configuration, we've got a replica set which has 5 nodes. With 5 nodes, that means that you can have up to 2 nodes not available, generally, and still be able to maintain a quorum in the replica set without having to manually intervene. So I'm going to walk through the different configuration options that we have here, but basically each of the 5 servers is configured slightly differently for a specific purpose. You'll see that each host has an ID. The ID is a numeric ID, which is automatically assigned when you add it into the replica set. This is basically an incrementing floating point number, incrementing number, which uniquely identifies that host. So if you actually took the host down and rejoined the replica set, you would actually still have the same ID number. If you physically removed the host and re-added it, you would end up with a new ID number. So when you start off, the nodes are going to be sequential, so they go from 0 to however many nodes you have, but eventually you may have gaps in the IDs, which is fine. There's a few different properties you can set. So this is basically, the configuration is the JSON configuration. So for each member of the replica set, you've got an ID, which uniquely identifies that member. You've got a host name, which would normally actually be the DNS name. And you have a few different options, such as priority and hidden. So in this configuration, I've got multiple data centers. In my first data center, I've got these 2 nodes. The priority is going to take effect during elections, which means during an election, the node with the highest available priority is the one that's likely to be, or that will be elected as the primary. So in this case, I'm encouraging votes to go to host A if it's available. If it's not available, the next most important node that I've nominated here is my host B. In a secondary data center, I've got another node, and this is just the default priority, which is 1. So in general, I don't want to have my node in the secondary data center elected unless the first data center actually fails. So if hosts A and B aren't available, then I'm happy for C to be elected. But in general, I want that to be a lower priority. Host number D, this is actually, I've got a host which is hidden. So a hidden host is one which doesn't, normally if you connect to a replica set, you can read from secondaries. A hidden one is one that can only be read from if you connect to it directly. So the reason for doing that is you can have a hidden node which could be used for analytics. So you may want to run map reduces or different queries against your hidden node without affecting, without having it in the regular pool. The last node here is actually a backup node, and the backup node here has a delay on it. So the delay means that it's actually going to be running 3600 seconds behind. So it's going to be, basically I've got an hour delay. So if I accidentally delete something or do something terrible on the primary, I've actually got an hour's window to actually go back and recover that from the backup node. So what does that look like when you're developing with replica sets? So basically we have a number of different options for depending on what level of consistency you want to get from your application. So this is really something that you control as the application developer. So if you want strong consistency, then you read and write to the primary, and the secondaries are only used in replication. So in this model here, basically if I write something to the primary and I use the same connection, I can then read the same information back. So it's basically read after write consistency. If you're actually okay with eventual consistency or delayed consistency, you can actually have a read preference which says you're okay to read from a secondary and you can write to the primary. This may or may not be a good thing depending on your application characteristics for performance, because the secondary still have to replicate all the operations from the primary. So reading from a secondary may not necessarily speed up the performance of your application. The main reason for doing this would be it does take some load off the primary. And perhaps in the secondaries, you're actually reading different data from the data set that you write. So if you're actually working with data on the secondary that's older data and you're loading that into memory, you maybe don't want to load that into memory in the primary. So the write concern is what you specify when you connect to the replica set. And you can basically say, this is the level of write acknowledgement that you want to get. And you can control that depending on what level of consistency you care about in your application. So the default up until recently for MongoDB was actually do unacknowledged writes, which means you basically fire it off to the database. It will get committed, but you're not waiting for an answer back to see if there was an error for it. So in some cases, you may actually, you could lose some data for that, which is basically called like a fire and forget concern. Recently, we've changed that in the drivers. So now the default is acknowledgement, which is wait for error. So what this means is after every update, it'll actually set a flag and wait to see if there was actually an error when that data was committed. The way that MongoDB works architecturally is that we use memory mapped I/O. So when you actually commit the data is written first to memory. It actually gets written into a journal file, and then the journal file gets applied to storage. So there's several steps there in terms of when the data is actually committed. So you can also say, set a higher level of write concern, which says you want to wait for journal sync, which means you get an acknowledgement back once that data has been applied in memory and also been applied to the journal. And you can also set a flag which says I want it to be replicated to a certain number of hosts. So you could say I want a write concern of 2. It must be committed to at least 2 other nodes aside from the primary in order to acknowledge the commit. We added another feature in MongoDB 2.0 called tagging, and tagging actually gives you even more control over that, where you can actually add tags to your hosts. So you can say this node is a data center in Sydney, or you can get it down to specifics of this is data center in Sydney, rack number 3, and then you can actually use those tags for both reading and for write preferences. So those rules can actually change without changing your application code. Your administrator can change the rules by tagging the replica set servers. So an example of tagging is we've got our 5 nodes again in the replica set. 2 of the nodes, the first 2 nodes are in New York. The second 2 nodes are tagged as San Francisco data center, and the last one is just tagged as mystically cloud. And then you can set error modes for that. So we can set a preference called all DCs. And so this is a custom tagging that we've set up in the configuration. If we say all DCs, this means that when you commit the data, you want to get acknowledgement that's been committed to 3 data centers. So that's based on the tags. So 3 data centers here would mean it would have to be committed to New York, San Francisco, and the cloud. There's another example there of some DCs, which says the data must be committed to at least 2 data centers. So what does that look like? Basically, waiting for replication. If you actually set a write concern of 1, then it's going to go to the primary data center. Write concern of 2 is going to go to the secondary. Write concern of 3, then it's going to write to the primary, secondary, and the cloud. And obviously, the more acknowledgement you need in the write, the longer you're going to have in terms of a delay on your insertions. So you can also do read preferences. So read preferences are saying where you want to read the data from. So the default is to read from the primary, to only read from the primary. You can also set a read preference of primary preferred, which means you prefer to read from the primary if it is available, but a secondary is okay. There's a read preferences of secondary okay, which is, or secondary, which is only read from a secondary. And there's a read preference of secondary preferred, which is I want to read from a secondary unless it's not available. And the last read preference is nearest, which is read from the nearest server by ping time. And you can also set up custom read preferences, so you could actually tag your nodes and say this is a node for analytics or for SSD, and then use those preferences to read from the specific nodes of interest. So operational considerations. The general intent of replica sets is to allow you to operate with no downtime. So basically there's automatic failover. If one of the nodes goes down, then another node should automatically step up, assuming you still have a majority of a replica set available. Another very useful feature of replica sets is to use them for maintenance. So if you actually had 5 nodes in a replica set, you could take down 1 or 2 nodes, do a repair or disk expansion or something on the node while it's out of the replica set, and then bring it back up without interrupting your application. So the application drivers will automatically take care of failing over to based on the replica set configuration. So your application connects to the replica set as an entity and doesn't actually concern itself with the details of what hosts are currently available. So here's a few different configurations. So basically, configuration number 1 is a single data center. So basically, we've got 3 nodes in a data center. And these could be a primary and a secondary and a arbiter, or it could be a primary and 2 secondaries. But you've got a single data center, single switch, single point of failure, well, multiple single points of failure. If any one of the nodes crashes, then the replica set will still remain available. So basically, you're allowed 1 node to crash. Expanding that scenario to 2 data centers, we could actually have 2 nodes in one data center and 1 node in the other. In this case, the node in the other data center is there as an example for safety or disaster recovery. So in the event that the data center number 1 failed completely, there aren't enough nodes in data center number 2 to actually fail over, but you do have a copy of your data. In the event that data center 2 failed, then data center number 1 is still going to be fine. And this example here is with 3 data centers. So basically, you can survive a full data center loss in this scenario. So each of the data centers has enough nodes to be able to maintain a quorum, as long as any 2 data centers are up, sorry. And you can add a write concern here. So you can say write concern to 2 data centers to guarantee that data has been written to at least 2 data centers. And right, so that's kind of the speed tour. Basically, the conclusion is just use it. It's really easy to set up. You can actually try it on a single machine. And there's lots of tutorials and information on that. And I think I have a few minutes for questions. Yes?
In the typical cluster setup I'm used to with MySQL, for example, we use a virtual IP, which is controlled by some other software which floats between the clusters depending on what node's primary. I noticed you never spoke about any of that with MongoDB, so I assume it's done in the driver on the client end, correct?
Yeah, so we actually have our own heartbeat in the replica set, so you normally wouldn't be using that sort of failover. Anyone else?
So, how do you feel about arbiters? Do you think that they were the right design decision?
Yeah, I think they're a useful tool in replica set configuration. I think ideally, I would personally feel better about having secondaries so you have more copies of the data. But in the event where you actually just want to have an extra node as in order to maintain the quorum for your replica set, or if you want to get something up in a hurry and have just spin up an arbiter rather than having a full secondary available, then they're a useful part of the deployment.
So I understand the point of that they feel sometimes as though you're kind of exposing an implementation detail of how you break a stalemate. They're a hassle. to work with.
I don't know if they're a hassle necessarily, but one thing that does confuse people is the name. So arbiters makes it sound like it's much more important than it is. It's really just a node that doesn't have data on it that is able to vote. So, yeah.
Any other takers?
Yes, sorry, just quickly. With the acknowledgement, so what happens with the triggered write or the triggered replication until it receives that acknowledgement? And what does it do if it doesn't get that acknowledgement?
So what happens with the acknowledgement if you haven't asked for it? Or?
So if you've got the acknowledgement comes through the system.
Yep.
Thanks. When the acknowledgement comes through the system, what happens to the data until it reaches or receives that acknowledgement? And then what's the strategy if it doesn't actually get the acknowledgement, if it doesn't replicate or something?
So basically that acknowledgement is something which is propagating the error back to the driver. So the normal strategy is data gets immediately committed in memory. It gets committed to a journal, which by default is every 100 milliseconds is getting flushed to disk. So it's basically an append-only journal. And then that journal periodically is getting synced to permanent storage. So the default for that is every 60 seconds it'll flush to sync that to disk.
So that will resend if there's an error and it doesn't actually come through?
If there's an error, then it's up to the driver. So your application would have to handle that error. So if the data didn't get inserted, or depending on what the error is, could be a duplicate key or some other error aside from... Generally the error is something to do with constraint, or with a duplicate key or another exception that occurs.
Okay, I was thinking more in terms of, say, there's a communications and network error or something like that, the replication fails, you've said that I want you've added the tag
Yep.
to actually... So what will the system do if it doesn't receive that acknowledgement in that sort of situation?
So the acknowledgement is something that you've asked for. So your application is going to get back and say there was an exception, and then your application has to decide how to handle that. So, yeah. So the data may have been committed. It depends what the actual exception you get is, but it's something you have to handle at the application level to decide: do you want to retry that, or what do you do with that? You could also say continue on error. I mean, basically it's a application level control for that.
Last one. In that case, thank you, Stephen.